Dun 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 dun. Da 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 da. Ba 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 ba. Anyway, okay. Kirchhoff's laws. Okay. What we're going to do here, ultimately what we want to do is we want to set up three equations with three unknowns. And the unknowns will be the currents in this circuit. And then we're going to use matrices to solve that. Just because we don't actually have to do the matrices, the poor calculator does, right? So our first step in doing this is to guess the directions of the currents. And there's going to be a current, separate current here, separate current here, separate current in this part, okay? So I am going to guess that there is a current that flows this way through this, because this is a little voltage source that's trying to pump current that way, right? So I'm going to guess I'm going to call that I current 1. Okay, I'm going to guess that it goes that way. Okay, and then I'm going to guess that there's a current. This guy's trying to pump current that way, right? So there's a current that goes here, here, here. And then I'm going to guess that the current must flow this way. Now, you just guess. We just write it down. You could guess, by the way, that all three currents flow upward, and knowing that one will be wrong. If you guess wrong, the current will turn out to be negative. Okay? So let's guess that the currents are flowing in this direction. Now, let's look at this junction right here. Okay? If I look at that junction, I will see that there are two currents. I'm going to call this current I2. I'm going to call this current I3. Okay, and the rule for the junction is that the sum of the currents flowing into the junction is 0. I prefer to say that that the currents flowing in equal the currents flowing out, because that makes more sense to me. But it's really all the same thing. So notice that I1 and I3 flow into this junction, and I2 flows out. So I1 plus I3 equals I2. That is, they flow together and become one great river flowing onto the sea. I think that's a Bill Staines song, is that right? Anyway, so there it is, right? Now, of course, if I look at this spot right here, I could also look at that junction, right? You're only going to have one of the current rules like this in this setup here, because you have only one unique junction. Let me show you why. Okay, so if we do this guy, I2 flows in, right? And then I1 and I3 flow out, right? Now, we haven't generated any more information. In fact, if you try to use these two things in your matrices, you'll just be like that guy that tries to tackle the football player and just totally misses, okay? So I'm going to just cross that guy out and just use this guy, okay? Now, I know I've got to turn that into a matrixable form, right? So I'm going to write it this way. I1 minus I2 plus I3 equals 0, because you got to get all the things with I1 on one side, put them in the order I1, I2, I3, put all the constants over here that don't have the unknowns multiplied by them, right? Okay, so that is one of my formulas. I'm just going to go. All right. The next thing I want to do is I want to do some loops here. Okay. So what we want to do is pick a spot and then just do a loop around. Okay. So I'm going to pick that spot for both of my loops, and then I'm going to go clockwise here, and I'm going to go clockwise on this side here. You have to visit every part of the circuit. Now remember, if you traverse, say we're going clockwise here, if we go this way through a battery from the negative to the positive, it's plus 13. Okay, and then if we go downstream through a resistor, as we would in this case, okay, it's minus IR. Okay, downstream is minus IR, upstream is plus IR. Okay, so let's just take a look. I'm going to start here, and notice that I'm in the current I1, and I go downstream because this current is going this way, right? I go downstream through the 5 ohm resistor, right? So the first thing I've got is minus 5I1. Okay, and then the next thing I encounter is an 8, and I'm going downstream still, right? So minus 8I1, and then there's a 13, right? So I'm going in the correct direction through that, so plus 13. Okay, I keep going, minus 3I1. Okay, now I pass this junction, and now I'm in I2, right? Okay, so let's see. But I'm going downstream, right? We guessed that that's going downstream. So minus 7I2 minus 13I2. And now I'm back. So I'm to 0 elevation game, right? Okay, so let's see. If we look at this, notice that we've got 5 and 8 and 3, right? So that's going to be 16I1, is that right? Yeah. Okay, so ultimately this thing becomes, when we matrix this thing, right? Minus 16I1. Okay. And then we've got 20I2, right? So we've got minus 20I2. And then we don't have any I3. And then the only constants we've got in that loop are the 13, right? So that equals negative 13. So all I do is I just sort of rearrange these. I combined all of the resistors. Let's just double check. Yeah, that's got to be 16, and we got 20, and then there it is. All right. This is good. This is good stuff. Okay. And then that equals negative 13. So this is our matrixable. We've got two matrixable formulas. We've got that, and we've got this guy. All right. Now we need to do another loop, except now we're going to go over on this side here. We're going to do this little loop. So we just did this little traverse. Right? And now we're going to go and do this loop. I'm going to go whoop, 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 whoop. Okay, so let's go whoop, 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 whoop. Okay, so let's see. I'm going this way, right? And I'm going to go through a 13 and a 7I2. So I'm just going to add those right up to begin with, right? I'm going to say, oh, no, I'll just do it this way. Okay, so, and since I'm going upstream, since I2 flows down the page and I'm going upstream, I'm going to go 13 plus 13 I2 plus 7I2. Okay, now I'm here, and now I'm still going upstream. I'm going to go upstream like a salmon the whole time. All right, so plus 4I3 plus 9I3. Oh, now I'm going through a battery, but backwards, right? So I'm going from positive to negative. So that's minus 35 is 0. Okay, let's just double check this. Plus 13 plus 7 plus 4 plus 9, 35. Okay. And then let's turn that into a matrixable form. Okay, there are no I1s. No man is an I1, right? Okay, I2s, there's going to be a total of 20 I2, so plus 20 I2. Okay, let's see. And then this is 13, right? That is 13 is that right? 13 I3s. And then what do we have in here? We got minus 35, so that equals positive 35, right? All right. Okay. Now we're ready. Now we're ready. Now we can set up our matrix, right? So this guy would be 1, negative 1, 1. All right. Then this guy's going to be negative 16, negative 20, 0, 0, positive 20, 13, right? And then we invert that matrix and multiply it by the answers, which are 0, minus 13, 35. let's just hope up that. Okay, so I've got a new TI-84. It's got the new operating system on it, right? And so if you hit the alpha key and then hit the underneath the screen, there's 5 buttons. Hit the zoom button. It's the middle button. Go alpha zoom, and you'll bring up a menu you've never seen before. Okay, and so what we want to do is we want to make a 3x4 matrix. And I'm sorry, 3x3. You can do it with a 3x4, by the way. You can use what is it, RF or something like that. But I'm gonna do it the way I wrote down here. Okay, then okay. Now let's go 1, right arrow, -1, right arrow, 1. No. Okay, there we go. -16 and -20 and 0. Okay. And then 20 and 13. And then I'm going to invert that matrix. And now I'm going to do the same thing. I'll go alpha zoom to pop another matrix. And this is going to be a 3x1. And I go 0, -13, 35. And in a moment, we'll see whether I totally wasted your time in the last 10 minutes. Ooh, look at this. This is so awesome. Okay. Okay, now let's see what my calculator says is that this is negative 0.34391. Okay, the negative means that this current doesn't go this way. It actually goes the other way. Okay, that's a little problem, but that's okay. That sometimes happens, even to the best of us. Okay, so 0.9251, I'll say 3. 92513, 92513. And then the bottom one is 1.26990. Okay, so these are our currents. That's I1, I2, I3. So let's fill in the answers here, right? Through the 8 ohm, and this is the trickiest one of all, we guessed that it's up, right? We guessed that it was to the left, up, and to the right. And we got that it was negative up, so it's actually down. So we're going to say 0.344 amps down. Okay, so it really goes this way. It's really going. Okay, and then I2, the 13 ohm has I2 going through it, right? We guessed down, we got a positive number, so it really is going down. Okay, so that's 0.925 down. Okay, and then the 9 ohm, we guessed that was going up, we got a positive number, and so it is 1.269, right, or 1.27. Right, we guessed that it would go up, and we were right. There we go. All right, so now we want to find the voltage across these guys, right? So the voltage across the 4 ohm is just IR. So for these guys, just use IR. And the 4 ohm has this current, the 1.269 times 4, right? So 1.29 times 4. That's 5.08, right? Okay, and then the voltage on the 5 ohm is IR. And the 5 ohm is here. It's on this side here, right? So it's the 0.34391 times 5. That's 1.7195 or 1.72. All right. So those aren't so bad, right? And then to define the power, you're always going to use I squared R. That's simply because I is what you get when you solve Kirchhoff's laws. You get the current, right? So I'm going to do I squared R. So the power for the 3 ohm is I squared R. And then the 3 ohm, where is that? There it is. It's going to be this one here, right? So 0.3439 squared times 3. 3439 squared times 3. Oops, I said plus 3. That'll give a different answer. Okay, 0.355 watts. All right, and then the power for the 7 ohm is going to be I squared R. And where's our 7? Our 7's in the middle. It's I2. I2 is 0.92513. Squared times, it's a 7 ohm that we're looking at, right? Okay, so 0.92513 squared times 7. 5.991. All right, now, dun, 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 the dreaded V1, and this one's made especially difficult because this current, you gotta keep in mind that current is actually going down. Okay, so let's figure out V1. Okay, so V1 is, okay, let's go down. I want to go from this side to this side, and I can either go this way or I can go this way. For this example here, I'm going to go both ways. So let's go anti-clockwise to get from this side to this side. And this is, by the way I put it as the absolute value of it, because I think I would go bug swatting mad if I had to tell you which side was the positive or the negative. Okay, I'd have to really think about that. I think I'm impaired in that respect. Anyway, okay, so let's look at this. I'm going to go this way. Notice that the current really is going down. Why is it going down? Because we guessed up and we got a negative number. So it really is going down. So I'm going to say it's 8 and 5 downstream, right? Do we all see that that's going to be 13, right? So 13 I1. So I'm going to say minus 0.3439 times 8 plus 5. So that's the voltage change from here to here. Okay, and then I'm going to go upstream through the 13 ohm, and it really is going down, right? So that's the 0.92513, right? So plus 13 times 0.92513. Okay, so here we go. This is it, man. Okay, so 0.3439 times okay, here we go. Okay, plus 13 times 0.92513. 7.555, 7.56. All right. So when I did it that way, I got 7.556 volts, okay? Okay, but now let's just for kicks, let's go the other way, right? So let's go this way, right? So we go plus 13, because we go from negative to positive, right? Now remember, let's see, this current really is going this way, so we're going to go plus 3 times that, right? So plus 3 times 0.3439. It was negative this time because we went downstream through it, but now we're going upstream through it, right? Okay, and then we go downstream through this guy to get to here, right? Because I'm trying to go from here to there, right? So I'm going to say minus 7 times, what's that middle current? 0.92513. And this is, of course, how you can check your work, right? Or you can just go, just totally crazy. Okay, so here we go. 13 plus 3 times 0.3439. 3439. Yep. Okay, minus 7 times 0.92513. Oh, it's the same thing. This is so good. Okay, I get, not that I've never solved one of these the whole way without making a silly mistake. This may be the first time. 5, 8 or something like that, but it's still 7.56, okay? So for this, for V1, all you do is you use the loop rule, only you don't make a full loop, okay? You just go boop, 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 boop. There you go. Or you go this way. By the way, I could also go, I mean, you could, if you really have a lot of time on your hands, you can go anything you want to do. You can go do, I can go here, right? You could go any way you want. You could do 5 laps of this and then come here, right? It doesn't matter how you get from here to here. Okay, the change in voltage will be just 1 voltage. All right, good enough.